Hi, I'm David Reed. I'm a landscape architect on the west coast of Canada. Welcome to the Adapting to Climate Change video series.
Climate change has already begun. This video series introduces how local community leaders on the BC coast are adapting now in practical ways to prepare for a future of ongoing climate change. We treasure this place, its magnificence, its ecosystems, all the life that's in it. We want to do whatever we can to live in harmony with our home, even as climate change brings some adjustments. Water and rain, rivers and oceans define this coast. Water is the focus of this video series. We're going to look into water's risks and benefits to communities in the face of climate change. Water is a key element in the wide range of British Columbia's ecosystems. Alpine areas and glaciers, wet rainforests, drier rain shadows, fjords and estuaries, islands, sheltered and exposed coastline. In each of these ecosystems, climate change will alter the pattern of temperature, rainfall, and snowpack, of drought and sea level rise on the coast. Vegetation, fish, and wildlife will need to adapt, and we will need to adapt our land use and our communities. Climate change will vary up and down the coast and across regions in BC. For information on current science-based projections of climate change and the impacts for your region, we recommend the Plan to Adapt website by the Pacific Climate Impacts Consortium at the University of Victoria. We also recommend that you watch Climate Insights 101. It's an online course by the Pacific Institute for Climate Solutions. The three-part interactive course provides more detail on climate science and adaptation planning, and it covers urban, agricultural, and forestry areas. Until you get a chance to explore more detailed information resources, some background is important to understanding the videos in this series. The temperature in British Columbia has been changing, and climate change will accelerate this change. Warmer temperatures influence the amount of snowpack, with streams, reservoirs, and aquifers having reduced inflows in some locations. The greater tendency to summer drought will increase water demand for agriculture and communities at a time when there is less water supply in nature. Precipitation in British Columbia has also been changing, and the variability and frequency of extreme events will expand with climate change. As climate change warms the atmosphere, it can hold more water. The trend is to increased rainfall, falling mostly in more intense fall and winter storms. These storms and rapid runoff increase the risks of flooding in our watercourses and damage to our infrastructure and our settlements. Climate change is also leading to sea level rise, with increased risks of flooding of our coasts and estuaries. Sea level rise will increase the elevation of tides at our shores. Combinations of extreme high tides, storm surge, and river flooding, although rarely occurring at the same time, can cause coastal flooding in areas that were formerly dry. For planning communities and infrastructure, it's necessary to understand the range of potential sea level rise. This is complicated by geological changes on the land. Some communities are gradually rising, while others are subsiding. But on a global basis, sea level rise has begun. Over the last century, average global sea level rise has been about 1 to 2 millimeters a year. The pace has increased to 3 millimeters a year between 1993 and 2010, leading to a cumulative average rise of about 170 millimeters across the globe. The rate of sea level rise in the future depends on many variables, including our reduction of greenhouse gas emissions, as well as the reaction of oceans and ice around the world. Melting glaciers in British Columbia are a significant worry for river flows and water supply, but are not the main driver of sea level rise. The largest changes are driven by surface water in our oceans. It increases in volume as it increases in temperature. Climate scenarios all predict rising seas, but provide a wide range of prediction for how fast the sea level rise will proceed. Much depends on the potential reaction of the large ice sheets of Greenland and Antarctica. For planning purposes, the Government of British Columbia is suggesting a sea level rise allowance of approximately 1 meter by year 2100 and 2 meters by 2200, compared to year 2000. These allowances are near the center of the range of potential scenarios. They will be refined as more data becomes available. The effect of these sea level rise allowances will vary on the BC coast because of the ongoing subsidence that lowers land in delta areas and tectonic activity that raises lands in areas of the west and north coasts. To adapt with no regrets, we need to contemplate where sea level rise will be at the end of life of a site or structure. If a building has a design life of 80 to 100 years, its design needs to anticipate where flood levels will be at the end of its building life cycle. The same principle applies to design of subdivisions or to management of habitats. How will they adapt to future flood levels that will rise gradually for centuries?
So look around. This is an ecosystem. It's not just a river. This is a river inside an ecosystem. And global climate change is affecting the entire ecosystem, so it's not just the fish. It's the insects, it's the bears that feed on the fish, it's the deer, it's the vegetation that grows in the area. We're already seeing an influx of more exotic plants and invasive species, changing the basic ecosystem of the region. So climate change is not just a simple matter. It affects entire ecosystems. And in order for us to understand the impacts, we have to study these changes in climate on an ecosystem scale.
As the ecosystem adapts, we also need to adjust our communities to be ready for climate change. The impacts of climate change on our homes and infrastructure won't be noticeable every day. It's the occasional extreme events that will make the headlines and cause the greatest hardship, like extreme drought that causes crop failure, or extreme river or coastal flooding due to a combination of storm surge, tides, wind, waves, and sea level rise that overcome existing defenses. The first step is to allow for climate change in our planning, design, and construction. If we anticipate future extreme events, we can avoid the worst consequences by a combination of thoughtful design and emergency planning. If we are prepared, we can minimize regret. We can learn to thrive with climate change.